everyone. I am Dr.J.BHUVANA, Assistant Professor of Chemistry, A.D.M.COLLEGE for Women, NAGAPATTINAM. Today, we are going to discuss about polymer techniques. This chapter belongs to second MSc Chemistry in Polymer Chemistry paper. Let us discuss the introduction of polymers. What are polymers? Polymers are high molecular weight compounds whose structures are made up of large number of simple repeating units. The interlinking of many units has given the polymer its name poly. What is meant by poly? Poly means many. The word mer means units. So, this is called as polymer. Many units, combination of many units, many monomers is called as polymer. Small molecules are combined to form a big molecule, that is called as polymers. It can be formed from one or more chemical compounds. So, for example, we take butadiene. It is a simple molecule. The combination of more number of butadienes, it forms polybutadiene. So, this is an example for polymers. Next, we are going to discuss about characteristics of polymers. What are the characteristics? Let us know. Polymers are having low density, economical, good moldability, corrosion resistance, poor tensile strength, poor temperature strength, non-toxic in nature and low cost. These are the characteristics of a good polymer. Next topic, we are going to discuss about our today's topic, types of polymerization. The reaction in which monomers combine to give polymers is known as polymerization. That means the preparation of polymer is also called as polymerization. It can be broadly classified into three categories. First one, addition polymerization. Monomers having double bond or triple bond, that means multiple bond, undergo addition polymerization. Monomers combine to give polymer through addition reaction without elimination of any smaller molecules. That means when addition polymerization takes place, no molecules will be removed, that means eliminated. The monomers are combined clearly. Therefore, the molecular weight of the resulting polymer will be an integral multiple of the molecular weight of monomers. So, for addition polymerization, example is preparation of polyethylene from ethylene. So, here the molecular weight of monomer is integral multiple of the polymers. First type is addition polymerization. Second type, condensation polymerization. What is meant by condensation polymerization? Monomers having same or different types of functional groups undergo condensation polymerization. So, that means the different functional groups can combine and form a polymer. That polymerization process is called as condensation polymerization. The polymerization proceeds by stepwise reaction between the reactive functional groups and the small molecules are eliminated. So, let us discuss In addition polymerization, small molecules are not eliminated, but there is a difference in condensation polymerization. Here, small molecules are eliminated and the polymerization proceeds between reactive functional groups. Example for condensation polymerization is preparation of nylon 66. Third technique is copolymerization. What is meant by copolymerization? It is otherwise called as joint polymerization. It is a special kind of polymerization. What are the special kind? The product is known as copolymers. It is superior to other polymerization because it is used to alter the hardness, strength, rigidity and crystallinity of the monomers compared to addition and condensation polymerization. Copolymerization is the best polymerization method. Next topic we are going to discuss about techniques of polymerization. What are the techniques involved to prepare polymerized polymers by polymerization technique? We are going to discuss about 6 types of polymerization techniques. Bulk polymerization, solution polymerization, emulsion polymerization, suspension polymerization, interfacial polymerization and gas phase polymerization. Let us discuss one by one. So, what is meant by bulk polymerization? This is the simplest method of polymerization. The monomer is taken in a flask as a liquid form and the initiator, chain transfer agent are dissolved in it. So, in a flask we contain monomer in the liquid form, another initiator, another one chain transfer agents. The flask is placed in a thermostat under constant agitation and heated. So, in bulk polymerization, we have monomer in liquid form, initiator that is mixed with the monomer, chain transfer agent is also added. So, we get a polymer. The reaction is slow but becomes fast as the temperature rises. When these additions are takes place, it will be slow. But when we heat the mixtures, we get a faster reaction. After a known period of time, the whole content is poured into the methanol, that is a non-solvent, and the polymer is precipitated out. Example for bulk polymerization is preparation of polystyrene from styrene. Okay. So, what is the advantages of bulk polymerization? It is quite simple, okay, and require simple equipments. The polymers obtained by this method is high purity compound. We have to know that we prepare high purity compound polymer by this bulk polymerization technique. As a monomer is solvent, excess monomer can be removed by evaporation method. So, the monomer is a solvent. If we take a monomer as a solvent, the excess monomer can be removed by evaporation. So, we can retain the monomer excessively. It has having high optical clarity. So, this is a optically clarity compound. Some of the disadvantages also present in bulk polymerization technique. What are the disadvantages? During polymerization process, viscosity of the medium increases. Hence, mixing and control of heat is difficult. Okay. So, mixing and control of heat is difficult. And another one important disadvantage is the reaction is highly exothermic reaction. We have to know that the reaction is highly exothermic reaction. So, these are the disadvantages of bulk polymerization. What are the applications of bulk polymerization? The polymers obtained by this method are used in casting formulations. Low molecular weight polymers also obtained. It is used as adhesives, plasticiers and lubricant additives. This is about first technique, bulk polymerization. Next type, solution polymerization. In solution polymerization, the monomer, the initiator and the chain transfer agent are taken in a flask and dissolved in an inert solvent. This is the changes from bulk solution. In bulk solution, we does not add inert solvent. But in solution polymerization, we are going to add monomer, initiator, chain transfer agent and an inert solvent. The whole mixture is kept under constant agitation. After required time, the polymer produced is precipitated by pouring it into a non-solvent. So, we get a pure polymer. So, what are going to add in the solution polymerization? Monomer dissolved in inert solvent, initiator, chain transfer agent. So, we get a new polymer. The solvent used in this method helps to control heat. Remember the point, the solvent, non-solvent used in the reaction helps to control the heat and reduces viscosity buildup. So, what are the examples of polymers can be prepared by this method? We can prepare polyacrylic acid, polyisobutylene and polyacrylonitrile can be prepared by this method. So, we see the second type, solution polymerization. Next, advantages of solution polymerization. The heat control is easy because we add the solvent. Viscosity buildup is negligible. The mixture can be agitated easily. That means the monomer, inert gas, initiator, chain transfer agent mixture can be agitated easily. What are the disadvantages? The removal of lost traces of solvent is difficult. This is the main disadvantage. The removal of lost traces of solvent is difficult. The polymerization, that means the solution polymerization requires solvent recovery and recycling. It is difficult to get very high molecular weight polymer. So, by this method, we does not get very high molecular weight polymers. The polymer formed must be isolated from the solution either by evaporation of the solvent or by precipitation in a non-solvent. So, this polymer can be isolated from the solution. This is their disadvantages. What is the applications? The solution polymerization polymers can be used as adhesives and coating purposes. This is the second type. Next, we are going to discuss about third type, emulsion polymerization. Emulsion polymerization is used for water insoluble monomer. Remember the point, water insoluble monomer and water soluble initiator. So, this polymerization takes place by the water insoluble monomer and the water soluble initiator like potassium persulfate. The monomer is disposed in a large amount of water and then emulsified by the addition of a soap. Then initiator is added. The whole content is taken in a flask and heated at constant temperature with vigorous agitation in a thermostat with nitrogen atmosphere. These are the procedures we have to follow in emulsion polymerization. First one, monomer is dispersed in a large amount of water. Then it is emulsified by a soap. Then add initiator. The whole content is taken in the flask and heated at constant temperature with vigorous agitation at nitrogen atmosphere. After 4 to 6 hours, it takes a long time. That means it takes 4 to 6 hours. The pure polymer can be isolated from the emulsion by addition of de-emulsifier. What is the de-emulsifier we use for this purpose is 3% solution of aluminum trisulfate. So this de-emulsifier used in this emulsion polymerization. So what is the procedure or reaction of this emulsion polymerization? Monomer, initiator and surfactant is added. We get the polymer in emulsion in water. What is the advantages of this emulsion polymerization? The rate of polymerization is very high. That means the process of polymer formation is very high. Heat can be easily controlled and hence viscosity is built up. High molecular weight polymer can be obtained by this method. Using this method, we can get the high molecular weight polymer. What are the disadvantages? The polymer needs purification process. While preparing the polymer, we have to purify the polymer, then only we can use that. It is very difficult to remove entrapped emulsifier and de-emulsifier. So, we have to remove the added emulsifier and de-emulsifier. That is a very difficult process by this method. Next, a very important disadvantage, it requires rapid agitation. That means vigorous agitation is needed. So, we have to use that type of shaker only for this purpose. These are the disadvantages of emulsion polymerization. What is the applications? It is used to prepare water-based paints, adhesives, plastics, etc. It is also used for manufacturing of butadiene and chloroprene. These are the applications of emulsion polymerization. Fourth type, suspension polymerization. So, what is meant by suspension polymerization? This polymerization is only used for water-insoluble monomers. This polymerization reaction is carried out in heterogeneous system. Remember the point, this reaction is carried out in heterogeneous system. At the end of polymerization, polymers is separated out as a spherical beads or pearls. This method is also called as pearl polymerization because the polymers look like pearls. So, the suspension polymerization is also called as pearl polymerization. The water-soluble monomer is suspended in water as tiny droplet and an initiator is dissolved in it by continuous agitation. The suspension is prevented from coagulation by using suspended agents like PVA, gelatin, methyl cellulose, etc. Each droplet of the monomer contains dissolved initiator. The whole content is taken in a flask and heated at constant temperature with vigorous agitation in a thermostat with nitrogen atmosphere. So what are the procedures for preparing this polymers by suspension polymerization? Means the monomer suspension in water, the initiator dissolved in the monomer, and the suspending agent are added. These are heated at constant temperature with vigorous agitation with nitrogen atmosphere. So, after the end of 8 hours, a very long process, after the end of 8 hours, pure-like polymers are obtained, which is filtered and washed by water. So, we get a pure polymer. Example for this method is polystyrene, preparation from styrene. What are the advantages of suspension polymerization? So, next one, the advantages of suspension polymerization. Since water is used as a solvent, this method is more economical. So, while using the water, this cost is very low. Products obtained is highly free, right? Isolation of product is very easy. It has efficient heat control. Viscosity buildup of polymers negligible. These are the advantages of this polymerization. What are the disadvantages? This method is applicable only for water insoluble monomers. Okay, this is a very important point. This polymerization is applicable for water insoluble monomers only. Control of particle size is difficult. This is the advantages. What is the application? Polystyrene beads prepared by this polymerization are used as ion exchangers. So, this technique is used in heterogeneous system. Next type, gas phase polymerization. This is also called as vapor phase polymerization, also known as gas fluidized bed polymerization. This polymerization technique is used for gaseous monomers such as ethylene, that means low density polyethylene, high density polyethylene, tetrafluoroethylene, that means Teflon, and polyvinyl chloride PVC can be used as a monomer for this method. Many other common thermoplastic polymers can be made by this method. This includes high volume resins such as propylene, methyl acrylate, methacrylate, vinyl acetate, ethylene vinyl acetate, and many other polymers that are stable in the gaseous phase can be prepared by this method. On industrial scale, vapor phase polymerization is mainly used to produce high density polyethylene and low density polyethylene. Next type, this method has the advantages. What are the advantages of gas phase? It has the advantages that it does not require any diluent and it does not have no residual catalyst remains in the resin or powder which is continuously removed from the reactor. A highly purified monomer gas is continuously fed into the fluidized bed reactor and combined with a dry powder catalyst. Polymerization occurs at the interface between the catalyst and the polymer particle which are swallowed with monomer during polymerization. The growing polymer particles shrink downwards and continuously removed at the bottom of the reactor and separated from residual monomer. So, by this method, we get the monomer is continuously fed into the reactor and passes upward in the reactor through a series of vertical reaction zones. At the top of the reactor, gas is removed, compressed and cooled, fed back into the reactor to control the temperature. This is about gas phase polymerization. Last polymerization technique, interfacial polymerization. A variation in solution polymerization is called as interfacial polymerization. In this method, one monomer of a condensation pair is dissolved in a ligand and another member of the pair is another liquid. The liquids are insoluble in one another. The polymers are not soluble in any forms at the interface between them. Also, one of the phases generally also contains an agent reacts with the molecule of condensation to drive the reaction of completion. In this method, we prepare the interfacial polymers. What are the advantages? The reaction proceeds very rapidly at room temperature and atmospheric pressure. In contrast to the long time at high temperature and pressure associated with polycondensation reaction. The separation of polymers from the interface is easier even during reactions. What are the disadvantages of interfacial polymerization? Separation of solvents and unreacted monomers may come too high. This is the disadvantages of interfacial polymerization. So, today we discussed about what is meant by polymers, what are the types of polymerization and what are the techniques to be followed for polymerization. These terms are discussed in this class. Thank you.